Hello, my name is Mark Pijnenborg. I'm a project developer, geothermal energy at Equans, previously called ENGIE. Welcome to this lecture on the district heating network of the TU Delft campus and part of the city of Delft. The goal of this video is to show you some heat aspects discussed in the previous videos and how they combine and are put in practice in concrete projects. In this lecture, I will showcase the development of sustainable district heating network using several technologies you have learned about in the previous videos. Secondly, the high temperature aquifer thermal energy storage, also called ATES, used for seasonal buffering of heat. A key element in the district heat network is the heat pump facility. And last but not least, all the challenges involved in the district heating network development. We start off by discussing the heat demand of the TU Delft. In the graph on the screen, you can see the required heating power of the TU Delft in a year. This shows that the peak demand during the coldest days is about 27 megawatts, while there's a full stop in the system in summer, which is very typical for the TU Delft. There's no students around, so no demand for heat. The surface area below this line represents the total yearly heating demand of 200 terajoule. Currently, the district heating network is fed by the gas-fired boilers and also the combined heat and power unit. But soon, a geothermal well will be installed to partly replace these conventional heat sources. And the geothermal well will provide sustainable heat to the campus. It also will give an opportunity for research and development purposes. As you can see in the graph, the geothermal well represented by the red line will only provide the base load of heat and will not be able to provide the peaks in heat demand. The total heat available from the geothermal well, when running at full capacity, a delta T of 20 degrees Celsius is about 235 terajoule per year. So potentially there's much more heat available than the 200 terajoule required by the TU Delft campus. However, due to this mismatch in demand and availability of heat, the geothermal well can only deliver about 135 terajoule directly. In order to close this gap, we need to apply large-scale seasonal heat storage. High temperature ATES, as it is called, is used to bridge the seasonal mismatch by storing heat in the subsurface. This improves the total delivery of heat from the geothermal well to the district heat network considerably, and thus better utilization of the sustainable geothermal heat source. During summertime, the heat is stored in the high temperature ATES system. In wintertime, the stored heat is used for the cold days. Using high temperature ATES with a 7 megawatt thermal power output and a seasonal storage capacity of 50 terajoule, the net energy shortage can be reduced to 15 terajoule. Thereby greatly reducing the dependence on conventional energy sources. The last important component in this district heating network I want to introduce is the heat pump facility. In this facility, 2 heat pumps are installed with a total heating capacity of 21 megawatts. The reason why we need to install this facility is to ensure the supply of the required temperature level and increase the yield of the geothermal well at the same time. Let me explain. The main goal of the heat pump is to increase the temperature level produced by the geothermal well to the required levels in the district heating network. The heat pump does also extract the heat from the district heating network return stream, and thereby it lowers the temperature of the geothermal well, hence increasing the delta T and the capacity of the geothermal well. The map here represents the new district heating network for the city of Delft. The future activities planned with this project at the TU Delft include realizing the geothermal well and the heat pump station. Secondly, connecting the existing and new district heating network. Thirdly, connecting the high temperature ATES for better utilization of the geothermal well. Thereby the heat pump facility really gets a central role in supply and demand coordination. Bringing together a large number of parties that are involved in the development of the district heating network also take some effort and really can also have an effect on the duration of the projects. In the development of district heating networks, various complexities and challenges are involved. Let us take a look at the major ones. The first one is matching supply and demand for optimum utilization of resources and reducing dependence on conventional energy sources. Secondly, multiple partners that are involved in the development of the district heating network. Working with multiple stakeholders really increases the complexity of the overall project. Decision moments on the various district heating network building blocks need to be aligned with interests of all stakeholders. And finally, we have a very rigid subsidy scheme offered by the government, and that also increases the complexity of the development of the district heating network. To summarize our learnings, we looked at the development of sustainable district heating network and discussed various building blocks. Starting with the high temperature ATIS, we learned about the benefits such as improved utilization of the available sustainable energy from the geothermal well. Then we looked at the heat pump facility and the benefits as a temperature service for the system. Finally, we talked about the challenges and complexities involved in the development of the district heat network. Thank you for your attention.